What is going on, guys? Welcome to this Python tutorial series for intermediates. Episode number 6 today will be about queues. And queues are data structures very similar to lists and sequences, with the difference that they have a specific order of how elements get into this list and how we can access them to get them out of this list. So let us get into the code. Now, in order to work with queues in Python, the first thing that we need to do is to import the queue module. So we're going to say import queue. Now, before we get into this, into the whole queue thing and how to create queues, how to work with queues, let's talk about why queues are even useful. So why should we use queues? The reason we should use queues is because when we have multiple threads running, if it's not just one main thread, uh, you need to have a structured way of getting in the data and getting out the data. Because let's say we have my list here, or let's take something else like numbers, for example. And I have a bunch of numbers here, for example, 10, 20, 30, 40, 50, 60, 70, and so on. And let's say I have 3 threads running. And each of those threads takes one of these numbers and processes whatever way processes this number. For example, it could use this number for a port check. It could use this number for a factorial calculation or anything like that. So basically takes the number or the element and process it. So when it's done with that, it has to access the next element that was not processed yet. So if we have 3 threads, the first thread will take 10, the second will take 20, and the third will take 30. The problem is now, when these threads are done, they need a way to say, okay, 20 was already used, because thread 1 will take 10 and the next one is 20, but 20 is already used or was already processed by thread 2. So we need a way to tell them the next free element is this one here, 40. Now, what you could do is you could say, give me a counter, and we're going to say how many elements have been processed. So thread 1 is going to take the first one, and it will increase the number by 1. Then thread 2 is going to take the second one, is going to increase the number by 1 more, and 3 and so on. But what happens when, for example, thread 1 and thread 2 finish their processing at the same time and increase the number both by 1? Then from 3, we would increase directly to 5, and everyone will think that this is the next number to be processed. And 40 would be skipped. Also, maybe none of them increases the number correctly, and we repeat the usage of the numbers. So not a very structured way to get for multiple threads to get data out of the same collection or sequence. So this is what we can use queues for, because when we define a queue in Python, and we do this by saying queue with a lowercase q, and then queue with a capital Q, basically this is how we create a queue, and a queue works like a queue, basically. Obviously, we just say put in some numbers. I'm going to use a comment for this right now. So let's put in the numbers 1, 2, 3, 4, 5, and these are now in the queue. And whenever somebody tries to get an element from the queue, doesn't matter which one, we cannot choose to get the element 4. We can choose give me the next element in the queue. It will give me 1. And the queue will look like this. It will no longer have the 1 in it. So the next thread that tries to get the element of the queue will get 2, and so on. So we basically pop out the element that's next to be taken out, and we're using it. So this is a very structured way, because we just put in a couple of elements and then we get them. And once an element is gotten out of the list, it won't get back into the list again because it's already used. And we cannot process the same element twice, and we also cannot skip elements because the queue always gives us the next element, so we cannot really skip it. So what we could do is we could create a numbers list, 10, 20, 30, 40, 50, 60, 70, for example. And then I say for number in numbers, I say q dot put number. So I'm taking all of these numbers and putting them into the queue. Now, to get these numbers, I just have to write q dot get. So basically, this would print 10 because it's the next element. And this would print, if I do it again, this would print 10 and 20, as you can see, because we're always getting the next element. And this is very useful when we have multiple threads, as I said, because now it does not matter. You know, if I have one thread and I execute everything in a linear manner, the problem, or I don't have any problems, you know, I just take the next element, and I could do this in a list as well. But when I have 20 or 100 threads accessing the same queue, it is very useful to just have this get method that always gets you just the next element. And once this element is out of the queue, it won't get back into the queue. Now, the type of queue that we used in this example was a first in, first out queue, which means that the first element that enters the queue is also the first element to leave the queue. If we want to reverse this, we can also create a last in, first out queue. So the last element that enters is the first element that gets out of the queue. So to do that, I again import queue, and this time I say queue dot last in, first out, so LIFO queue. And it's basically the same thing, just that in this case, if I create a list of numbers here, and I say for x in numbers, q.putx, when I now print the get element, so when I say q.get, I will get the last element that entered the list, so I won't get 1, but I will get 7, because it's just a reversed order. Now, another very important queue, or very interesting queue, is if you want to do this a little bit more manually, you can define a priority queue. So if you don't want a first in, first out, and not a last in, first out queue, you can create a priority queue. And this priority queue allows you to give every element a certain priority by passing a tuple. So I can say q.put, and then I have to specify a priority. And the lower the number, the higher the priority. So 1 would be the highest priority, 100 would be quite low, 2 would be still pretty high, and so on. So I can give this element a priority of 2 and say it is hello world. And then I can say another element gets the priority number 11, for example, and it's a number 99. And then I give it another one, which has the priority of 5. And this is a float. And then I can say q.put priority number 1 is, I don't know, true, or something like that. And then I can just go ahead and print the elements of the queue. Or actually, I can print this in a different way. So I can just say while not q.empty print q.get. So as long as there are elements in the queue, we're going to print the next element. And here you'll see, what is G? Oh, Q, sorry. I know why I typed G. So here you can see that we get the priorities, but actually we should get the, oh, I know why. I need to pass this here as a tuple, because otherwise it does not work. And this one here. So we get the tuples in the order of priority. As you can see, I wrote it down like 2, 11, 5, 1, but I get 1, 2, 5, 11 because it's sorted by priority. And I can access the actual value here. So these are more or less key value pairs, just ordered tuples. I can just go ahead and say, for example, 1, and I'll always get the values in the right priority order. Now, if you're interested in seeing an example of how to use queues in an actual project, you can go ahead to neural9.com and click on the blog here. I'm going to show you how to get to the blog. You click on the blog, then you go to networking. It's a little bit laggy right now. Then you go to port scanner in Python, and here you see a tutorial about how to create a threaded port scanner in Python. And what I use here is I use the queue module so that I structure the port numbers so that I have multiple threads running, 500 threads maybe, that scan for ports. And so that they don't scan the same port twice or don't skip any ports, I use queues here. Also, I have the same video on YouTube, so the same tutorial in video format here. You can find it also on neural9.com. So if you're interested in an example of how to combine threading, sockets, and queues, check out neural9.com. So that's what you need to know about queues for now. In the next video, we're going to talk about sockets and network programming. So we're getting into some really advanced stuff right now. Up until now, we talked a lot about classes, objects, threading, and now we're getting into a new topic of sockets programming, of network programming. So stay tuned, keep watching the videos, hit the like button if you enjoyed the video and learned something. Feel free to ask questions and give feedback in the comment section down below. Subscribe to this channel if you want to see more, and see you in the next video. Bye.